Welcome back to Data Science series. It's day 6 of our 30-day journey to mastering NumPy. Today we will explore data types and typecasting in NumPy. Understanding these fundamentals is crucial for manipulating data effectively. Let's get started. Is data types. In NumPy, data types are an essential concept that determines how data is stored and interpreted in arrays. NumPy provides a rich set of data types that are more efficient and flexible compared to standard Python data types. In overall, understanding NumPy data types is crucial for efficiently working with large data sets and performing complex numerical operations in Python. By specifying appropriate data types, you can ensure both accuracy and efficiency in your computations. NumPy's comprehensive data types system provides flexibility and control over how data is stored and manipulated, making it a cornerstone of scientific computing in Python. Here I imported the NumPy library as NP, then I created a one-dimensional array from 1 to 5. Then let me run this A and you will get an array from 1 to 5. Then let's check its data type. Then use this variable a dot d type like this. Then you will get d type int 64. Int 64 is a data type in NumPy that represents 64-bit signed integers. This means it can store both positive and negative whole numbers within the range of approximately -9 qutillion to +9 quintillions. Now let's do it with floating points. Here is my one-dimensional array of floating points. Then let's check its data type b dot d type. Then run this and you will get d type floats 64. Float 64 is a type of number in NumPy that can handle very large or very small decimal numbers. It can represent numbers as big as plus or minus 1.8 times 10 raised to the power of 308. It also keeps the number accurate up to 15 or 17 digits. Here my C variable contains an one-dimensional array of filled with string values. Let's print its data type. To do this, c dot d type, and let me rerun this. You will get u1. This data type less un is a NumPy data type that represents a Unicode string with a maximum length of one character. The lesser than indicates the byte order little endian in this case, but for Unicode string this is less than relevant. Then U stands for Unicode string, then the one indicates the maximum number of characters the string can hold. So the D type lesser than UN means that each element in the array is a Unicode string that can hold up to one character. Last data type is Boolean. Let's check its data type. To do this, d dot the type data type, which is d type. Then let me run this and you will get d type bool. In NumPy, the bool data type is used to represent Boolean values. Each element of a Boolean array can hold one of two values, which is true or false. The key point is values can be either true or false. And about memory usage, Boolean data types typically use less memory compared to other data types because they are only need to store two possible values, true or false. Is typecasting. Typecasting, also known as type conversion, is the process of converting a variable from one data type to another data type. In NumPy, typecasting is particularly useful for ensuring that data types in arrays isn't in the correct format or various operations, enhancing both accuracy and performance. In NumPy, you can use the astype method to cast an array to a different data type. Now let's change this integer value to floating point value. To do this, let me add a new code cell. Inside it, say float equal to, then call the variable int underscore values like this, then put dot, then as type method with a set of parentheses inside it float like this. Then let me run this float. You will get an array of decimal values. Now let's reverse this process. Let's typecast the floating values to integer value. To do this, let me create a variable integer equal to, then call the float like this, then as type with a set of parentheses inside it int like this. Then let me run this integer, and you will get an array of integer data type. Now let's typecast the string values into integer value. To do this, let me create a variable integer equal to string dot as type with a set of parentheses inside it int like this. Then let me print this integer, and you will get an array of integer values. Let's typecast the boolean values into integer value. Let's do this. I equal to, then call the variable b dot as type with a set of parentheses inside it int. Then let me run this. You will get an array of integer value. Finally, let's typecast the integer value to boolean value. To do this, let me create a variable p equal to, then the I dot as type, and with a set of parentheses inside it bool like this. Then let me print this. You will get 0 as false and other numbers are true. Understanding NumPy data types and typecasting is crucial for efficient data manipulation and numerical computations. Data types like int64, float64, Unicode string, and bool serve specific purpose, optimizing memory and performance. Typecasting using astype ensures compatibility and flexibility in operations. Converting between types like integer, float, strings, and booleans, mastering these concepts enhance your ability to handle data accurately and efficiently in scientific computing tasks. Thank you for watching, and remember to like, subscribe, and comment in the description below.